Welcome to the Infrastructure Podcast. My name is Anthony Oliver, and today we are talking about decarbonisation of global aviation, and specifically a new project that aims to leverage the growth in nuclear technology to accelerate us towards a new world of affordable e-SAF, sustainable aviation fuels. Because for all the pressures of driving towards a net zero emissions future, the world's hunger for air travel continues to grow, which leaves the environmental cost of traditional kerosene fuels as no longer sustainable. And to be honest, given the impact of the war in Iran, the pressure to accelerate towards new types of fuel is only going one way. Well, today I'm joined by Caroline Longman, Director and Guiding Mind at nuclear energy consultancy Equilibrion, and by commercial lead Hannah Vickers. Together, they're going to talk us through a potential solution, Equilibrion's flagship e-SAF project, Eq.flight. Now, decarbonising aviation is a tough challenge, perhaps one of the biggest challenges of the global net zero transition. Unlike road transport, which can lean on batteries, long-haul flights require high-density liquid fuels. And global SAF mandates are tightening. The EU and the UK have already mandated a 2% SAF blend by 2025, rising to 10 to 22% by 2030, making now an increasingly critical moment. And whilst sustainable aviation fuel exists, the current bio-based methods face a feedstock ceiling. There simply isn't enough waste oil or land to fuel the global fleet. Well, the Eq.flight program attempts to change that equation by leveraging the carbon-free power of nuclear energy and working in collaboration with partners like Rolls-Royce SMR. Equilibrium is moving from consultancy to delivery, recently launching a call for partners to join a trusted, outcome-focused supply chain. So let's hear more. Caroline and Hannah, welcome to the Infrastructure Podcast.
Thank you very much. It's great to be here.
Thanks, Anthony. Thanks for having us.
Well, look, Caroline, let's start with a bit more scene setting. I mean, you say Eq.flight is more than a pilot project. You say it's a blueprint for a global fleet of modular production facilities. So for those new to the concept, I mean, give us the elevator pitch. Why is nuclear energy the secret ingredient for sustainable aviation?
So, first of all, nuclear energy is one of the lowest carbon forms of energy across the whole life cycle of the energy source. It is an energy source that works. It's been delivered and generating energy for decades. So we know this technology works, and it's been around a long, long time. We're able to deliver nuclear from within our own shores. We have capability to manufacture and operate nuclear plants, and within the UK, we're one of the best in the world at doing this. So in terms of the actual energy source, it's high density, it's high capacity on an incredibly small land area, orders of magnitude smaller than what you require for an equivalent amount of energy from offshore wind and solar.
Well, that's the point. Because e-SAF is not new, but typically it's produced using renewable energy such as wind or solar. But the key thing now is that because we have like smaller modular reactors, that is the key thing.
Absolutely, yeah. So around the world, and in particular in the UK, there is a really progressive government policy towards nuclear energy. We want to build more. We want to build them on sites which weren't previously designated as nuclear sites. We have advanced technology now, which allows them to be assembled off-site in factories and then built on site. So in terms of the nuclear policy and progression of the nuclear industry, that's really looking positive, and you'll see in the news Rolls-Royce, GBN, and there's other policies that have been put in place to encourage development. So in terms of Eq.flight, we want to leverage this progressive industry and utilise that high density, high capacity, low carbon power to make SAF.
And I'm sure, Caroline, you've heard the excellent podcast with Ruth Todd back in January of this year, which she describes the progress they're making towards small modular reactors at Wilfer, etc. But I mentioned these global SAF mandates tightening. I mean, clearly now is a critical moment. I mean, is that the main driver for you? Is that what's driving the market right now?
Yeah, the market is driven almost entirely by the mandates, and the mandates are there to encourage airlines, encourage the industry to decarbonise. So in short, yes, that drives that. That's going to create our market. There's challenging mandates in the UK, there's challenging mandates in Europe, and actually across the world, they're starting to develop at a rapid rate. So it certainly is going to drive our market.
And fast forward to right now, you're currently seeking expressions of interest for partners to join the programme. You highlight 5 areas: technology, engineering, construction, off-takers and infrastructure, and fuel users. And we're going to discuss it more in a moment. So briefly, why do you need those partners right now?
So if I just take a step back, our project Eq.flight is a system that will utilise nuclear energy to generate e-SAF. Now, we have been funded by the Department of Transport to take us through the early engineering stages. That funded period is just coming to an end, and now we're gearing up to the front-end engineering design, the detailed design, and ultimately construction for our first-of-a-kind commercial plant to be online by early 2031. In order to be able to do that, we need to bring together the best partners we absolutely can to take us through that first-of-a-kind. But actually, this is a platform for deployment and co-locating these systems with nuclear energy sources within the UK and across the world. So we want a partners that can stay with us through the whole journey.
Right, yeah. And I mean, 5-year time scale to get the first one up and running, that's pretty punchy. And I suppose that's why you need those partners on board right now. Well, turning to you, Hannah. I mean, Hannah, firstly, welcome back to the Infrastructure Podcast. We last spoke in episode 88 back in November 2024. Check that out, of course, if you haven't listened to Hannah speaking there. You've just joined the Equilibrion team from a role leading Mace's advisory business. Before that, of course, you were at Treasury driving its major project's commercial strategy. So what's your role here? You're leading the task of seeking these partners for the global projects. What's the commercial and procurement strategy that you're putting together here?
So I've had the great pleasure of joining the EQ team to work on the early stages. It's very similar actually to what I used to do in Treasury. So this is all about initiating the project, standing up the first strategy. And we're now at the point where we can sort of move more formally into commercial strategy. So, we've got our feasibility done. We're ready to start to pick up these commercial partners. Now, I guess the big challenge or the big difference for me compared to doing this in government is there are no rules now. We are a startup, and I think that's actually really exciting because it means that we can do the very, very best version of this. So this isn't a collaborative partnership in just name. This is about companies that actually want to come in and literally buy into the program with us. So yes, we're seeking complementary capabilities and expertise. We want companies out there, and you've listed the range of disciplines, but we want companies that are going to make a real impact on the program. And actually what we want is for them to truly buy into this. So everything from, sweat equity through to sort of framework agreements. That's what this is about. We talk about Project 13, but this is actually being able to do it.
So this is working. I mean, I talk about, what the commercial and procurement strategy for the project is. I mean, it sounds like pretty much you're going to be talking to these potential partners and working out what that strategy might be or what that arrangement might be. You've got a pretty open mind, have you, at the moment?
Yeah, absolutely. Because, we are a startup. So there are things that we're absolutely excellent at around strategy and policy and creating the market and obviously the relationships we have deep into nuclear, but we know there are areas, particularly around delivery, around looking at high risk construction, but also optimizing some of the engineering processes and design that we want the best supply chain partners. But what we think we have got here is a really compelling proposition for them, because as Caroline referred to, this is a program that will repeat around the world. So if you're in now, we really do sort of form together in the partnership and go on a sort of 15, 20-year journey together.
Yeah. And clearly also the need to transition to e-SAF will impact the development of infrastructure at airports. I mean, because there will be a need for an awful lot of different infrastructure constructed there. How might this technology help or influence the investment that airports are making?
So I think there's two different levels to this. There's the practical side of actually the distribution, but to be honest, and Caroline will probably add to this, that it is a kind of drop and go fuel. So that doesn't, if you imagine the infrastructure going into Heathrow, for example, it doesn't have to change substantially. But I think the more interesting part is what it enables from a net zero perspective, because actually you won't be able to do an airport expansion under the current 7th carbon budget and the net zero legislation without having a clear commitment and a clear target, because they won't meet their carbon budget. So you can't do Heathrow expansion, you can't do Gatwick expansion without a way of the airport actually being able to demonstrate it is accessing the SAF market.
Yeah, Caroline, sorry, you were going to add.
I was going to say something along the lines of the drop in fuel point, but actually, as well as net zero, there's no way e-SAF is competitive with fossil fuels right now on a price per barrel sort of like for like basis. But if you look at the Iran war and what's happening around the world, we're already halfway to seeing comparable prices. So there is very much an energy security and fuel availability perspective that we can actually make this fuel. And we're not reliant on volatile fuel prices.
That's a very interesting point. But so building on that then, Caroline, I mean, how does this Eq.flight project bridge the gap between the UK's nuclear heritage and its future as a leader in green aviation? I think you're already working with Rolls-Royce, is that right?
So yes, we are.
But I imagine expanding out those partnerships is key in the nuclear world.
Absolutely. So what is different? What is our value here is how you couple the SAF production plant to the nuclear energy source. So we would be a co-located facility, and we would take off the nuclear heat and electricity from the reactor to power all stages of the SAF production process. So our value is how we link the two, and we work with the nuclear. We have a nuclear heritage ourselves. We're a nuclear background. Our entire careers in nuclear, so we have the relationships and the understanding of the regulatory, the siting, the technical, and the policy challenges around nuclear deployment. And that understanding really puts us in a good place to understand how we can couple these systems together. Rolls-Royce we've been working with for some time to grow this understanding, and we've developed that relationship over the course of many years, accumulating, as you'll have seen in the MOU. And we continue to work with them as they progress their own deployment ambitions. So it's an exciting time.
Well, we're going to get stuck into. I'm going to get you to talk us through the technology in a bit more detail, Caroline. But first, Hannah, just going back to these partnerships, and you mentioned Project 13, which you were very involved with. I mean, how do you see these partnerships actually working in practice then? And what is the overlap with that kind of work you did on Project 13?
So although we have no rules, it's not simple, because actually what we've got is a delivery model that spans both a programme level and a project level, because we know we will have some partners that may just want to work on a particular site with us, a particular project, or just work in a particular jurisdiction. And we might have others that would be quite happy to, say, for example, do, owner's engineer around the world as a global partner. So what we're doing is just looking out there into the market, because there's so many different ways that we could structure this. So the next 4 weeks and the expressions of interest that we have out at the moment is all around getting the partners to come forward and say, look, we know what we're good at. We could structure this with all of you at a programme level. We could structure it on a project by project basis. We could have a mixture of some of that and the roles that you would have a delivery partner or an EPC or an EPCM. We're open to looking at all of those. Yeah. But I think crucially, and the link back to Project 13 is, yes, we've got this potential delivery model at different levels, but actually how we decide which partners to go forward with is the critical piece, because, we're so early in terms of the development of the projects and the programs and the system optimization, that actually we want partners that will come in and really help us to make this as profitable as possible.
So talk to me about skills, and what particular skills have you got in mind?
So some of the things that we think are particularly important, but again, what we're going to go out with these are our capabilities, these are the risks and these are the opportunities we want to hear from the market. So some of the things we've identified, obviously we need sort of high risk, complex construction skills, because, you are building a fuel refinery next to a nuclear power plant. It's not low risk. So, we need some of those.
You're making me nervous.
Deep, complex. No. Construction skills. We also need really good process optimization, because again, once this thing is built, it's operating 20, 30 years. So, the profitability comes from really, really good integration of the different technologies and how you optimize that use of heat and electricity from nuclear. So we need some really clever engineers to do that part. And then we're going to need some specialists. So this isn't just for the big guys out there. We actually really need some specialists around, some of the things that will contribute to the system overall, like the control systems. So quite a range. But...
Yeah. Well, hopefully the things which the UK has got a vast amount of expertise in from the nuclear energy sector that perhaps haven't really been given the opportunity to innovate in this way. Caroline, let's get stuck into the technology then. Give us a few more basics about the technology. From what I read, Eq.flight utilises a so-called power to liquids pathway. I don't know what that is. So talk us through. How do you turn water, air, nuclear energy into drop-in jet fuel?
Okay, so Eq.flight itself is an integrated system of multiple proven demonstrated subsystems, so individual technologies where combined produce the fuel. So in a simplest form, it consists of an electrolysis component which produces hydrogen, and that electrolysis will use the nuclear heat and electricity to make the hydrogen. It includes an element of direct air capture, carbon dioxide capture. So effectively, it's taking carbon out of the atmosphere rather than out the ground.
Right. And
then it's combining those two molecules into the fuel. Ultimately, there's a few stages down there with the upgrading to actually get your jet fuel. But ultimately, that's it. So you take your carbon dioxide and take your hydrogen, and you combine it, and you make the fuel. That whole process uses an awful lot of energy, and the process can be made vastly more efficient by the application of heat. So that's it in a nutshell.
So, which leads to my next question. Is it theoretical right now, or is it a practical, deliverable reality?
Absolutely not. All the core technology...
at scale I'm talking about, at scale.
Yeah, all the core
outside the laboratory.
All the core technologies exist today. So the IP that we've developed is not in the individual technologies. They already exist. These technologies have been demonstrated. It's how those technologies are integrated is where we come in, and how you apply that heat across the whole system and utilize the constant nuclear heat, always on. It doesn't just generate heat when the wind's blowing or the sun's shining. It's always on, combined with the application of heat directly across the whole system, which means it can be scaled, and it can operate and generate SAF at scale from a very small land area.
Yeah. And as you said earlier, I mean, Equilibrion's got a background as a nuclear consultant. You've done this stuff before. You've also got I saw on your website, you've got a nuclear to hydrogen project on the go. I mean, presumably there's overlaps in those kind of projects which you're running there.
We do, yes. So we're really lucky. So we started out as a consultancy, and we're now moving to project development. But in terms of the consultancy, we've got a lot of work. We work very closely with the gas networks to understand, as part of joint projects, how hydrogen can be delivered into the gas networks for multiple applications. So we do look at nuclear for other applications. SAF is one. There's other types of synthetic fuel. There's e-diesel, there's hydrogen, there's direct industrial heat, and others. So the principle is the same, is utilising direct heat to make these products.
Yeah. Well, Hannah, I mean, one of the things which you've done a lot of work on over your career is this whole idea of modularising the delivery of infrastructure. I mean, how does the modular design of Eq.flight allow it to scale more rapidly than perhaps traditional bespoke chemical plants, from your perspective?
So, I mean, if I compare it just to traditional infrastructure for a second, I think that the modern term, Anthony, is industrialised construction. Now, we're not allowed to talk about modular anymore.
Right, it's easier to say as well.
We've been rebranded, yeah. But no, so I think that's in effect what it is. And I guess what we are looking for is, because this is very, very technology heavy. So actually, the size, shape, the configuration of the technology doesn't change, but what you're really looking for is the ease and particularly the pace at which you can get this onto site and constructed. Because actually, the SAF mandates, they are time bound. You don't want to be holding up Heathrow or Gatwick expansion because there's not enough SAF capacity. So actually the industrialisation here is the buildings itself, may not be that complex, but what's the most efficient way? What's the quickest way for us to get those up and to get this whole system functioning as quickly as possible? And how can we replicate that around the world? So it is, I don't want to say kit of parts, but that's what we're looking for here, is what are the construction partners, or who are the construction partners that can do that, and then actually make sure that that is replicable around the world. So it's investable, it's reliable. You're buying into this whether you're in the US or Canada, and you know how much it's going to cost.
Well, I mean, clearly, Caroline, one of the questions you hear when you talk to people about hydrogen, and I imagine it's a similar argument here, is that converting nuclear power into heat and electricity and then back into e-SAF, it's quite a journey. I mean, in terms of efficiency, how much energy from a nuclear reactor can be actually utilised? And is that a journey which is likely to become more efficient the better at it you get?
Yeah, I mean, so our first of a kind will not use nuclear energy. It will simulate nuclear energy to demonstrate how you can apply thermal and electricity energy across the system.
Right. So you don't have to wait for the first SMR to come online before you can roll this out in 2031?
Absolutely not. No, we will be rolling out in 2031, but in parallel, progressing the nuclear deployments when the first nuclear reactors come online in the mid-2030s. And ultimately, you can use the entirety of the output of nuclear energy to deliver 160 million litres of SAF a year, which is a significant amount and will make a significant impact on the mandates.
Right. Well, personally, Caroline, just talking about your career, you've worked in the nuclear sector for 25 years, in the private sector with Nuvia at Harwell, and consultancy with Fraser Nash, and also with government as a secondee at the Department for Business Innovation and Skills and the National Nuclear Laboratory. It all kicked off, though, for you with a degree in physics. So what attracted you to the nuclear sector? Because it wasn't that sexy back in 2001, as I remember.
No, it wasn't. When did the Energy Act come in? 2004. The government decided to build new nuclear. Before then, it was all about decommissioning and taking them down. I came into the nuclear industry I was a radiation protection advisor.
Yes, I was going to mention that, actually. Yeah, that sounded... Well, it sounds quite a scary job role. It
was scary. It was very, I mean, it was. I worked off. I didn't work on licensed sites in operational health physics in the beginning. It was all around supporting. I worked for government, supporting sort of government trips to countries as part of the non-proliferation arrangement. So I got interesting trips to Russia to make sure that contamination control was in place, etc. So I had very much a kind of scientific beginning to the nuclear industry, and only later on I started to kind of move into business development and out that technical role.
But I suppose it back in when you started, it was all about managing the decline of the nuclear sector, whereas today it's about actually managing the acceleration of it. That presumably makes it a more attractive sector.
Oh, absolutely, yeah. I mean, the vast majority of the spend was in decommissioning. We lost a lot of our key skills and industrial capabilities because the industry declined, and then it's starting to rebuild itself. But we have to rebuild those skills and capabilities. So, I mean, without a doubt, when I worked in government it must be 10 years ago, the Hinkley Point C was going through its final investment decision, and UK supply chain was gearing up to be able to take as much of that content, that supply chain content as possible. And now, obviously, with other developments and overseas developers and technology vendors coming into the UK, wanting to build out technologies in the UK, there's even more opportunity because it's such a big driver, provider of jobs and supply chain content for regions. There is great interest in hosting nuclear deployment. So we're quite excited about it, and it's really good, a good source of reindustrialisation, if you like, of the UK, if we can get the nuclear sector going.
Yeah. No, so you set up Equilibrium in 2022. I mean, was there a light bulb moment where led you to say we need to focus on the intersection of nuclear energy and aviation?
So myself and my business partner, Phil Rogers, we had similar career paths, and we worked together in the same companies in the kind of, 2016 onwards, I guess.
And started as radiation protection advisor.
He didn't, no. That's just for me. But yeah, and we've done work both in government and in the national lab, and really trying to understand the potential for nuclear to deliver other products other than the baseload electricity that we know today. And we could see policy changing, and we had a role in that policy changing. It was a bit of a light bulb moment. We decided that we wanted to actually, rather than sit in a big organisation, be a smaller cog. We actually wanted to use the rest of our careers to drive a real change in the sector and create a market for nuclear energy. And if we do it from the pull rather than the push, we could make a difference. So we left our jobs and set up the company and took a risk.
No, well, I mentioned my conversation with Ruth Todd, and it's genuinely, there's a potential to be a transformational, not just for the nuclear sector, but for the UK's industrial base. To be quite honest, it's there's the modularisation, the off-site fabrication, etc., the industrialisation. Hannah, you would say. Well, to attend to you, Hannah, I mentioned your background in infrastructure. How does the culture of Equilibrium differ from traditional public sector infrastructure clients?
I'd say differ is the right word rather than be better or worse, because I think there are good things and bad things in both, because what we've got here, we have a completely blank sheet of paper. We've got some really strong capabilities, a really strong team, but we don't have at this stage, any of the sort of, legacy governance, all the stuff that's talked about in the Stewart review around HS2, all of the, the layers of approvals and things. It's so quick and so dynamic to be able to, to just do the right thing, if you like.
You're more agile.
I don't like that word, but yes. But yeah, and actually, when you're trying to do something innovative and you're trying to do it at pace, you need that. You need to be able to say, we're going to hit 2030. What's it going to take for us to hit 2030? And let's get on with it.
Yeah. But you spent 3 years at Mace. And some would say that they're a pretty transformational business in terms of the ability to do things quickly, to change and to adapt and to be agile, to use a word you don't like. What attracted you out of that role then into this consulting role?
So I enjoyed my 4 years with Mace. The majority of that I was with Mark Reynolds as his chief of staff. So, actually my role there was to help Mace grow up and sort of get ready for the, now publicised Goldman Sachs purchase. So I was trying to take something which, if you like, was the world's largest SME and put some governance and sort of structure around that. And the opportunity with Equilibrion is actually at the opposite end of, you can set it up right at the very start and try to put the guardrails and things around it. So it was just a different take on the same skill set, really. And it's obviously very, very different, very, very different culture, very, very different industry. I'm getting to learn all about nuclear in a depth I didn't in Mace. But to be honest, I think that's what's quite nice is I'm able to bring that, sort of delivery heritage and that commercial mindset to move this from what it has been, which is the feasibility, the technology, the kind of proof of concept, into actually we're going to have a commercial plant now. Well,
of course, Mace has changed it quite a bit, so maybe a good moment to change course. Carol, let's talk a bit more about the potential partnerships that you're launching right now. What's the reaction been from off-takers, the airlines and the fuel distributors, to the prospect of a nuclear-derived fuel? Does it matter to them? Is it all about cost, I imagine?
It is all about cost and availability and timescales as well. So in answer to your question, we've had a huge amount of interest from off-takers, and we're talking to off-takers constantly. We have the recognition that this is actually, this is a realistic way of scaling e-SAF, which has been the challenge, is starting to get some traction. So we are seeing more and more interest as we move forward. And we still challenged by the longevity of our project. This is a long-term solution, and we can't pretend it isn't.
No.
We're going to deliver we're delivering our first of the kind, which is a nearer term, this decade solution. But ultimately, the prize here is transformational in terms of the ability to deliver, SAF at scale in the long term.
We say long term, 2030, 2031, it's not that far away. Hannah, I imagine, not very far, no. But Hannah, I imagine that the first thing you said to Caroline was, goodness me, 5 years, that's not enough time. What are the key milestones the supply chain needs to hit to get to that first demonstration project by 2031.
Yeah, so I mean, we're just at the moment about to sort of transition into the feed phase. So the expressions of interest is around designing the delivery model, but ultimately we will be then looking for requests for proposals for the feed, which, if you like, is the detailed engineering design of the first commercial plant. So that's really important that we kick that off this year, and sort of included in that phase, you do the important things like finalising the site selection, obviously then moving into the planning process. We do the detailed design, but we also do the site-specific design for it. And we start to look at things like the construction rehearsals. We start to look at the feasibility of when these things arrive and how you construct it. What's quite interesting, I think, in this space is it's very technology heavy, which isn't usual for how we construct infrastructure in the UK. So again, I think we're going to be really sort of testing some of our commercial partners with some of that, because in theory it is already modular or industrialized because it arrives in modules. So it's a quite a sort of
which
unusual...
is the way that it happens in the petrochemical and the chemical world.
Mm-hmm.
Yeah. It's a kit of parts that come as you assemble a kit of very complex bits of technology.
Yeah, so we should be able to do it super quickly, shouldn't we? That's what I'm hoping our supply chain partners tell us.
And how are you designing this delivery model to avoid the usual infrastructure? I mean, it's happened in nuclear, to be quite honest, and that's a battle that Rolls-Royce are going through to try to avoid the single project trap, to ensure you can be repeatable and you can be deliverable and deployable globally.
So there's different aspects to that. So there's the kind of the technical side, which, being technology heavy does help us to being repeatable and deployable around the world, because actually a lot of our technology vendors are global, so you can order one to be delivered to the US or to the to North Wales. It doesn't really matter. So that side of it to some extent is simpler. I think what we're looking for is actually those partners that can come in at the program level, at the very top, who can work with us on optimizing this system. Because if we get that right, and if we can get that learning going from project to project to project, if you think about this, I know we want to talk about the construction and the infrastructure front end, but actually the real money is made in the operation of this. So what we want is really quick, reliable construction that then delivers a super efficient fuel production facility for the next 20 or 30 years. So, those are the partners that we want that can design that system and can say, right, this is what we're going to learn. This is what we're going to measure. This is how we're going to use data on the first commercial plant to optimize the design for the next deployment. And that's the bit that will actually make us far more money than we'll make from any construction.
Yeah. Well, let's talk a bit about challenges and barriers. Caroline, public perception of nuclear, it does remain a hurdle for some. And I imagine when you're looking at locations, the obvious place to build this kind of plant is near a nuclear power station. I mean, how do you communicate the safety and the green credentials of nuclear-enabled SAF to the flying public, or the public in general, the communities that are around these facilities?
Yeah, I mean, you're right. It remains a challenge, and the public vote for governments, and governments make policy. So we need to convince the public that the nuclear energy is the right solution, and no one will tell you a stronger story than those who have lived in the vicinity of a nuclear plant and can see the benefits, and in terms of jobs, in terms of supply chains, in terms of community jobs for generations, than the people living there. So really, the challenges around deploying nuclear in areas which haven't seen nuclear before.
But one of the other things, of course, other barriers is the skills gap we currently have in the UK for professionals, particularly professionals in the nuclear sector, and people who understand both nuclear and chemical engineering. I mean, is that going to be holding you back, or is this an opportunity to, have you got the time to upskill the nation, so to speak?
We're really fortunate in the sector that there's quite a number of initiatives being developed, and as a result of Hinkley and some of the future deployments, X-Energy hope to deploy at Hartlepool, and there's quite a number of initiatives already ongoing that recognise the skills gap and what needs to be done to address that. But that said, there is still a skills gap, and there is. I think we need to recognise that nuclear is a big construction project. The actual nuclear bit is relatively small compared to the construction skills that are needed for the whole project. I think there's a skills challenge across the industrial sectors more generally. But we in the nuclear sector are taking steps now to make sure that we've got the right workforce. But there's no doubt it's a challenge.
No, I was going to also talk about a barrier being cost. And of course, I was going to say e-SAF is currently more expensive than traditional kerosene aviation fuel. But of course, right now, that probably isn't the case. And I don't know, whether it will continue to be. Who knows what the price will be in the future with what's coming out of Iran. But is there a roadmap to bringing the cost of e-SAF down towards the previous cost of a kerosene-based aviation fuel? Yeah,
I mean, at the moment, as I said before, you can't compete at the moment. But we're already with the price increase since the Iran war. We're already halfway there to being competitive. So it's not going to take a huge amount more for actually e-SAF to be competitive. It's not at the moment, and we need, it does need that government support. But we recognise that over time, and as we deploy more and more systems, that the cost has to come down. And it's high at the moment, as it is with any emerging technology. But one of the reasons that we're really starting out with a long-term sort of approach from a single platform is that we can bring those costs down over time.
Yeah. Well, Hannah, you're currently navigating arguably two of the most regulated industries on earth, nuclear and aviation. Is that a daunting prospect, or does that give you kind of opportunities? Because having those really well-defined rules makes arguably things more straightforward.
It's useful because you know what you're working with. I mean, obviously there are things which are looking to influence the approach to regulations, such as the Fingleton Review, which we know the government has adopted, and they are actually committing to dates as well when some of those recommendations, particularly around then scaling nuclear. So that, I think, if done correctly, should speed up the siting and the development phases of the future nuclear plants. So that will certainly help from a regulatory perspective there. I guess the other piece to throw into this from our perspective is we're global. So yes, there is that in the UK, but there are other countries that are perhaps a little further along with some of their, regulatory reform around needing to have that energy security, around, really wanting to make sure that they're self-sufficient from an energy perspective. So, again, as we start to scale, we're not going to be constrained by the UK. We will be doing our, first of a kind commercial in the UK, but there's no reason why we couldn't sort of, hop over to the US and see Mr. Trump and get some plants out there. Not that he'd want to buy sustainable aviation fuel, but
that's a similar strategy for the Rolls-Royce SMRs. Of course, they're starting in the UK, but they see that as a big global expansion model that they've got there. So I suppose if they're going abroad, then there's no reason why you can't tag onto the back. But Caroline, looking at the UK market and looking forward, as Eq.flight develops and is deployed at scale, what percentage of the UK's aviation fuel demand do you think could realistically be met by your systems?
So ultimately, we're working towards utilising the entirety of an output of a nuclear reactor, and you can meet a big proportion of the mandates with that. So without starting to quote figures, which I wouldn't want to do, we can make a huge difference. In fact, we would see that those mandates could be increased once we've developed this solution at scale.
And is there an opportunity to, I suppose, future-proof it if suddenly the need for aviation fuel disappears? Can this technology be used to produce hydrogen or other fuels as the market evolves?
Absolutely, yeah. So we are focusing on SAF at the moment because of the mandates and government policy. However, the process is broadly the same. The coupling is the same, and we're absolutely already looking at other products because fossil fuels replacement is required way beyond aviation. So there is this technology. These systems could be used to produce a wide variety of fossil fuel replacement.
Well, just to wrap us up and finish us off, just both. We'll start with you, Hannah. If you look back, I don't know. We say we're in 2050. What do you see as the potential legacy of a project like this for the global, this vital global energy transition we face right now?
No, I mean, I think this is transformation. If I go back to Caroline's purpose for setting up Equilibrion, it's, it really is that ability to be able to recognise that nuclear energy doesn't just have to give us baseload electricity. There are so many more things, and I think particularly pertinent at the moment, because actually, if you were to turn around to Keir Starmer and say, we can, in the UK, we can fabricate these synthetic fuels so that we don't have to rely on importing from the Middle East, and that can be anything from aviation fuel through to hydrogen. That is transformational. I don't, that for the first time I sort of got my head around that as a concept. I thought this isn't actually just about can we keep the lights on. This is about can we reinvigorate our whole industry or create a whole new industry, and whether that's in the UK or around the world. But I think that's the legacy really. It's a whole different way of thinking about energy.
Which goes to the heart of why for me anyway, why SMRs are so exciting. Caroline, what about you? What would you say the legacy of this project might be?
I think energy resilience. I think the skills and the jobs and the UK industry can support. If we can deliver cost competitive fossil fuel replacements, we can develop a green industry and support industrial growth in Britain, which in of itself creates jobs. So this is really important to us, and one of the reasons why we set up the business. New industries, new sectors, new jobs, new skills. Absolutely. That's exactly what this UK continually cries out for, which is all underpin the mission for growth, one might presume. Anyway, thanks. So really, really interesting project. And I like to tackle some of these things on the podcast, which are kind of are just really interesting and really exciting. I think this is definitely ticks those boxes. So great to meet you, Caroline, and great to catch up with you in your latest endeavours, Hannah. Certainly, I say, very interesting, very challenging, potentially hugely influential projects, and I will be keeping an eye on it for sure. So thanks so much for making time to join me with the Infrastructure Podcast today to explain the plan.
Thanks for having us.
Thank you.
My absolute pleasure. Sadly, though, that's all we've got time for on the podcast right now, but there's lots more in the pipeline as we continue to probe the big issues facing the sector. If you haven't done so already, do check out the Infrastructure Podcast website, www.infrastructure-podcast.com, where you will find the background information and all the latest podcasts to listen to and to share. So thanks for joining us. Thanks again to Caroline and to Hannah, and I look forward to seeing you again very soon.